talking to you today about significant figures and mainly just operations with decimals involving significant figures. Because significant figures only come into play depending on what operation you're doing. So, a significant figure comes from the fact of if we have a number and we have place values given to them, written down, then what's written must be significant. Otherwise, why is it written? For example, if I have the number 900, if I have the number 900.0, or if I have the number 900 point or 0900. Well, you would say all of these are the same value, right? That's true. They all have the same value of 900. There's no difference in any of them. However, actually, I'll make this one be 0.00. The first one, how many significant figures does it have? Oh, well, it has three numbers written, so those three must be significant. No. It only has one significant figure. Sometimes people call those sig figs. That has one sig fig. Well, why? You said if it was numbers written down, then they must be significant, right? Yes. Well, what number is actually written down? Because remember, zeros represent nothing. The 9 is. The 9 is written down. This could have just been a rounded value, for all I know. This could have been 899.999. Someone's just like, I'll just write 900. This could have been 900.000001. And someone could just be like, I'm just going to write 900. The only thing I significantly know is that this is around 900s, or is 900 exactly. So the significant part is the 9. Kind of like when we were doing scientific notation. We talked about that, like the highest place value is the part that made that was important. Same thing here, but only because the rest of it are zeros. Got it? All right, cool. Let's go to the next one. 900 again. This time written 900.0. How many significant figures are there? Oh, well, there's one, right? Because this was last time. No, this one has 4. Well, what? There's 4 digits written down. How did that happen? You said the last time that it didn't matter. Well, I put a decimal there saying that, hey, I know that this is 900. Like if I were to say, hey, I'll give you $900. I give you $899. You're not really gonna know a difference. Like you probably will. You're like, hey, where's my $100? Or maybe not, because you're still like, I got $899 on you. Or if I say I'm gonna give you $900, I gave you 905, you don't really think anything about it. But if I write you a check and I say 900.00, you're expecting exactly $900, right? So that is why that's significant, because that decimal is there. So this has 4 significant figures. Because the decimal being here means there are 0 ones, 0 tens, there are 900s, there are 0 tenths. Okay. I'm starting to feel you. Mr. Stevens. I got you now. All right, so the next one. No trick question here. No trick question, right? Yeah, no trick question. Okay. All right. So I got 900 in a decimal. So this is gonna have 3 significant figures because that decimal's there. Yes, that's right. It's gonna have 3 significant figures because that decimal is there. Again, saying, hey, I know for a fact this is 900. Okay, cool. All right. Think you're getting this, right? Yeah, I got this. I can do this. All right. So we got a 0, a 9, a 0, 0, a period, 0, 0. So this one has there's a decimal there, so this has 6, right? Yeah, almost had it. This has 5. Well, but the decimal's there. Yeah. And the decimal tells us that this is exactly 900, right? The 0 in the front, what does that tell you? You had no thousands? Okay. Does that matter? No. There could have been thousands there. Someone could just write 900. Well, but the decimal's there. The decimal's there to let you know that these numbers, these 2 zeros are significant. Anything in the front that's leading has no significance whatsoever. Even if we had 0.005. Not significant because they're in the front. then the significant part is right here, this 5. So this would have just one significant figure. All right? It'll take some time to get used to, but once you get the hang of it, pretty much any leading zeros, notice I said leading, that means there's no other number in front of them, just zeros. Sometimes people see they'll see 1, 0, 0, 0, 0, and like 9, and think that those don't count. That's not true. Leading zeros never matter. Trailing zeros without a decimal don't matter. Trailing zeros with a decimal, they matter. Zeros in between two numbers, they matter. And that's significant figures. But again, I said they really don't do anything for us until we get to operations with them. So let's talk addition and subtraction and multiplication and division with significant figures. Okay, so let's say we had 3.785 plus 4.231. Okay, if you added this up, this has 4 significant figures. We talked about that. This also has 4 significant figures. Your answer should have 4 significant figures. Good. It will have 4 significant figures, but it's not because you're using anything. So when it comes to adding and subtracting, our significant figures are actually not based on how many we have in the first one and how many we have in the second one. They're based off of where our decimal is or where our last value is. And so let me change this problem. Let me do this now. So we have 4 significant figures here, and we have 2 significant figures here. So if we added this up, we will get 7.985. Okay. Well, we had 4 significant figures at the top, so we went down 3 decimals at 3 values after a decimal. Second one, we only had 1 value after a decimal. So our final answer should also have 1 value after the decimal, because the smallest one of these had 1 value after the decimal. Okay, that's pretty simple, right? So when it comes to addition and subtraction, we look at the decimals or the end values, and we see which one has the smaller amount, which one moves up the closest, and that's what we go off of. So this had 3 numbers after the decimal, this had 2, so our final 1. So this our final answer is going to have 1 number behind the decimal. So we would have to round this so that it only had 1 number behind the decimal. So we need to round here. Well, I have 7.985. How do I round that? Go to the 8. Is the 8 in the upper half of our digits? It is, so this rounds up. So that 9 becomes a 10. Well, how do I write that? Do I write 7.10? No, because that wouldn't be rounding up, would it? To make this 9 into a 10, we would have a 0 go here, and you would add the 1 to the next place value up. So this would become 8.0. And that's how you add and subtract with significant figures. Okay, I can do that. So I just see what the smallest number of decimals are, right? And I add it like normal and then round it in to however many decimals I need. You got it. That's all you do for addition and subtraction. No tricks. That's exactly what you do. Now make sure you don't round until the end. A lot of times people will decide that I'm going to round up here and then add down. And if you did that, you would have ended up with the same answer. But that doesn't always happen like that. So make sure you don't round until the end. It is a very important fact when it comes to mathematics. Do not round until the end. Unless your boss tells you otherwise because he doesn't know it better. That happens. But round at the end, the last step you do before. Because if you do it at the end, then your answer is going to be more accurate. If you do it every step, your answer gets less and less accurate. Okay, what about multiplication and division? So I wrote 200 down. How many significant figures does it have? Okay, good. Only has 1. No decimal. So let's do 200 times 48. That has 1 sig fig, or significant figure. 48 has 2 significant figures. All right, good job. Now, we need to multiply these two numbers. Well, if we do that, we end up with 9,600. Okay. Well, the last time we looked to see what had the smallest number of decimals with adding and subtraction, right? Kind of the same concept when it comes to multiplication and division, except we're looking for the lowest number of significant figures. So this had one significant figure, this has two. So our answer should only have one significant figure. Well, how many does it have right now? Two. That's right. Still no decimal written. But it needs to only have one significant figure. So how am I going to do that? Well, I need one significant figure, so I'm going to round this up. Again, I got a 9. So if I go to the right, I have a 6. That's in the top half. That rounds that up to a 10. So we have 10,000. Does that have one significant figure? Yes, it does, because there's no decimal there, and these are trailing zeros. Good job. You're getting the hang of it. All right, so we'll do one more. Okay, so we got 3.430 divided by 0.07. Okay, cool. I'll make it a little easier on you. You may use your calculator and whatnot. I won't go into detail on dividing this. You can look at dividing decimals if you're having trouble with that. We divide this. We get 49. Okay, well, how many significant figures do we have in the first one? Well, in the first one, we have 4 significant figures. Okay, how many do we have in the second one, in the denominator? Well, these are all leading zeros, and there's nothing in front, so we only have one significant figure? That's right, you only have one. So we had 4 in the first and 1 in the second, so our answer should only have 1. So we need to round 49. Well, if I round 49, I go to the right of the 4, I get a 9. 9 is in the top half of our digits, so we round up, and this becomes 50. Okay, let's change something with this problem. If I had a 0 at the end of it, I have 4 still in the first one, but now I have 2 in the second one. And I got 49 as my answer. Why do I have 2 significant figures? Because this is now following after with the decimals. That tells me that this is significant. So I had 4 in the significant figures in the first one, 2 in the second. My answer should have 2. All right. What if I added another 0 down here? This now has 3. Top still has 4. This still has 3 now. I only have 2 digits. How do I make this to have 3 significant figures? Because it ain't 3 now. Just add a 0 in with a decimal. Now I have 3. Okay. Another thing you can do is write it in scientific notation. That's what a lot of people do sometimes. So I'll change this to 4.90 times 10 to the first. Because now they can add zeros on the end to have significant figures however they want. All right. And so that is operations with significant figures. Remember, when it comes to adding and subtracting, you go off of the least number of decimals you have, so up the highest place value, and whatever that is, that's what your answer is rounded to. When it comes to multiplication and division, you go off whatever the smallest number of significant figures is. And I will get a new board and see you soon.